A student who is good at learning science the traditional way typically knows a lot, but even those students struggle to apply that knowledge except to answer test questions. Research has shown that a different teaching approach serves all students better.
I do stars for every single bird that I find, so I just wrote down 5 stars because I saw
More students understand and get excited about science, and even those who did well in the traditional class gain deeper and more usable understandings.
1, 2, 3, stand up, walk around, and read everybody silent museum walk.
To achieve this, the three-dimensional learning in NGSS offers students more than only one dimension to draw from. Through science and engineering practices, cross-cutting concepts, and disciplinary core ideas, the NGSS focus is on comprehensive performance tasks that allow students to show how they use science ideas to explain and predict phenomena.
On your map, put stars where you think you would find these birds and their nests.
And then on the back, jot some reasons why.
This video highlights a project-based learning, or PBL unit, which is one research-supported method for achieving the goals of NGSS.
B2. So put B2 on the back. Write your reason why right here.
Because it has tall grass and they live next to some water and their food. That's the same spot I chose. But I chose these. No.
PBL engages students in meaningful phenomena and has students create an artifact to explain and predict new phenomena or solve problems in the real world.
We saw like a red-winged blackbird on the grass. Most of them we got like very close to it. And got to see like the red turn on its wing.
This third grade unit took kids outside to collect data to figure out why the red-winged blackbird has red epaulets. It used the real-world phenomenon of birds interacting in a marsh to explore the idea that traits influence social behavior and thus access to resources.
We're gonna take a little walk. What do we see out here already? Make some observations. What do you see them doing? What do you notice about their epaulets? Do they change?
The males always puff up the feathers when they call to each other. Maybe to say this is my area, this is my nest and territory.
And I see that they're calling. Probably for help or to track, like find like love and track the females.
In 3 of these videos, we offer case studies of students engaging in the NGSS through PBL, and in another, we will introduce their 2 teachers.
So I wanted them to understand that what they're studying is also what scientists are studying, and that they are scientists in the same way, and they're also conducting experiments and looking for information and testing out their own hypotheses, which they did with their field trip. Where are they going to build their nests? And some of them even changed their hypotheses when they saw the data that they had collected.
The opportunity for those kids to come to these discoveries by themselves without us just telling it to them, I think gives them a deeper understanding.
Each student's interests and strengths are solicited and leveraged through the project-based unit design for three-dimensional learning. Initially, teachers Alice and Dom introduced the driving question of the unit to their students. The question is meant to engage the students, develop a thread throughout the unit, and motivate the need to figure out the problem.
This is called the epaulet, and only the males have them. The epaulet is often red, sometimes orange, sometimes has yellow and white in it. On the tables, we have pictures of the red-winged blackbird with the epaulet, and we're going to invite you to walk around with your pencil and write different ideas that you have for what the epaulet is for.
I think it's for survival, to scare away predators, and my evidence for that is because some other animals do that.
What other animal does that?
Like different kinds of bugs.
Next, the students made predictions. They thought about where in the marsh they would see the blackbirds and made connections between their own experiences with the birds and the features on the map, like the lake and the marsh. By making a prediction, they are invested in the data collection.
So where do we think that we're going to find the most red-winged blackbirds if we started looking tomorrow? We want to find a place that has a lot of them flying around so we get a chance to be great scientists and observe.
And then you're going to put on there, you're going to circle your quadrant where you think the most nests will be.
Why do you think they're going to be there?
Because there's water and there's long grass.
In the marsh, the students kept careful track of the red-winged blackbirds they sighted, both males and females. They noted the behavior of the birds and where they were found.
There's another one! There's two more blackbirds! Oh, hi, little booties. We found a bird that has orange epaulets.
I think that he's calling for a female because he's making the same call over and over again.
Back in the classroom, the students analyzed the data they found.
Put it overlap it.
Overlap it.
What do you notice about this map? Okay, Finn, why don't you start?
Most of the bird spotting are in quadrant A3, and I think part of that is because most groups went to A3 and they both saw the most birds because probably saw the same bird.
The students figured out that some niches have more resources than others, even in the same environment.
B1, there's the least amount of birds, maybe because there's not like a marsh or a lot of grass.
Why would the food be different in that spot? Do you want to ask the class if anyone has an idea?
I think that there's the least amount of birds in B1 because there's mostly water there instead of land. Therefore, there will be less birds.
The class developed claims about what the red epaulet was for. Watch for student reasoning.
This is my territory, and puzzling themselves out to make them look fierce.
When you want to be social with someone, do you have a way of showing them? When you want to be social, what do you do?
Put on my hat.
The students read a study from Stanford University researchers.
With the Red Wing Society system was suggested by experiments, which are the patches of adult males were dyed black.
This part here, what is the function of the red wing's badge? Does it serve to distinguish red wings from other blackbirds, or does it signal status within Red Wing Society? Are there any words there you're not sure about?
And they developed new claims based on the new evidence.
What about when they're hiding it? Are they being aggressive?
No. I think when they're hiding their epaulets, they're trying to say maybe I already have a female in my territory.
Forest?
Last,
Prairie.
the students put together
And
a
over
role
here
play
we have
to think about how the epaulet
water.
might
Does that
influence complex
Water.
social systems
And
that
here,
impact
let's see, this is the
resources
road.
for the birds.
Whoever decides to be a male red-winged blackbird is going to choose a spot. You're going to choose your territory that you're going to own, okay? Okay. So choose your spot. When you find a place, just start pretending to build your nest. So you're going to be doing this when you decide to build your nest. Okay, go find a place. Now we have the male red-winged blackbirds come back and see where you claimed your territory.
And using the core idea that some animals benefit from social behavior and the cross-cutting concept, structure, and function, teams engineered a solution to indicate if they are competing for resources or interacting and communicating socially.
We need to make it an open square. You get some, then we'll...
I like your idea. I'm going to do red and green too.
This means leave me alone, and this means you can come and play with me.
With three-dimensional learning and project-based design, the students were agents in their own learning, and they felt successful. Parents also remarked on the shifts happening in the classroom.
Science at an earlier age, which just gets kids more interested earlier, which is good. It piques their interest and they're more willing to observe things that they normally wouldn't even notice in everyday life.
They noted their children were seeing STEM as an area they could succeed in. And most of all, they saw their children enjoy learning science.
But yeah, it took a lot of courage for a lot of these kids to stand up and share some of these things that they weren't sure were correct or incorrect, but they just had these ideas and they were able to communicate in small groups and then have the courage to stand up in front of a group of their peers.
Transforming how we go about teaching science not only benefits students, but changes teachers. Enabling students to be agents in their own learning and creating opportunity for powerful learning enhances the educator's identity as STEM teachers.
That's what scientists do. We need to observe where we're finding the most. If you saw any
Teaching project-based learning and the next generation science standards is challenging, but rewarding. It allows the creative genius of teachers to emerge and students to be engaged and feel successful.
This means back up off me. This one is like when I want to play. Thinking of you.
These videos show how PBL and three-dimensional learning allows these amazing, creative, curious kids to succeed in STEM and see themselves as scientists.